Hello everybody, thanks for coming. So today I'm going to talk about an initiative that we've been doing at Element 4 around tasking satellites. It has a name as of our last sprint called SpatioTemporal Asset Tasking, which I'll get to in a minute. But first I want to talk about what exactly is a satellite tasking API. We use the term, and satellite companies use this term tasking, but actually what they mean is not really tasking. We're not actually tasking satellites. That would be actually kind of crazy if you just let users task satellites. What we're really doing is users are ordering data from the future. If they're ordering data from an archive, we have STAC for that, and that allows you to search the data lake. But ordering data from the future has just come to be known as satellite tasking. And there's no standard around satellite tasking, and so every satellite company out there has a different spec, and they come up with a new API every single time. And this makes it really difficult for users to be able to to shop around, really. Like it doesn't lend itself to a very good marketplace of satellite data because you have to now implement a client for every single API. So if we had a spec, we could really empower users to be able to go and look at different companies, especially now with the proliferation of small satellite companies, and be able to compare what images are available from the future for their needs. So how do we get there? Well, I have this naive view of things around adoption, around how we generate specs. The key thing is about adoption. And when people adopt specs, they will implement clients or servers, and this adds to the software ecosystem. The greater the software ecosystem grows, then the more adoption. So this is a circle of life, if you will. More adoption means a larger software ecosystem feeds more adoption. So we can bootstrap this process by doing outreach like I'm doing today in order to increase the adoption, and we can use open source software development in order to bootstrap the software ecosystem. Most of my ideas around this really come from the development of STAC, where we started STAC and did exactly this, where we really focused on implementations and the ecosystem around it in order to show users what we could do if there was a spec. And so the recipe here is we're trying to accomplish the same thing. So we've been holding sprints, and we want to drive this adoption through a sense of ownership. It's one thing to go to satellite companies and say, hey, implement this spec. This is what in the US government is one of the big purchasers of satellite imagery, and they'll go to the satellite company and say, you have to adopt this spec. And it's not a really great system. By including satellite companies within the process of developing the spec and making sure that the spec will handle their needs, then we instill a sense of ownership. And this, I think, is how we get to the ultimate metric of adoption. So we had a sprint, and we convened a whole bunch of folks at our office in Alexandria, Virginia. We had a mix of users and satellite companies that came, and we had a lot of conversation around what would be needed in a spec. We talked about the parameters, we talked about contracts, products, order status, all this, and it was really some great conversation, and we did have some key takeaways, like we should be using other standards where we can, such as GeoJSON, and we needed the concept of some sort of product. And we got to that idea that users aren't really tasking satellites. The main concept that we got to after all of this was this concept of feasibility requests. And this isn't really anything new. A lot of satellite companies have this idea of feasibility requests, where rather than a user giving all sorts of options to the satellite provider and trying to pass along preference about what it is that they want and having the satellite decide, we thought that it would be best if the satellite user, if the satellite provider actually pushes choices back to the user. So this is the concept of a feasibility request, where a user has their parameters that they want to meet, they send it to the satellite provider, and they get back a list of options. And now they can sort through those options based on whatever criteria it is that they want, whether or not it be price, or latency, or view angle, or whatever it may be. Rather than having the user rather than trying to encapsulate preferences within this request to begin with. So push choices to the user and push the complexity to the provider. So if we think about something like stereo imagery, we really don't want to have users to have to task both of those images. And so in that case, that complexity really should be handled by the data provider. So stereo imagery would be a product. And the data provider, the satellite provider, is going to determine how best to meet that request, what the offset is in order to achieve the needed parallax in order to get a proper stereo image. Now, the one thing that we didn't do was any implementations. And so by that metric, it sort of felt like that first sprint was actually a bit of a failure. We came out of it with a whole lot of notes. It was great to be all in person and talk about these things, but we really didn't have anything to show for it. And that's what I wanted from the beginning. But we did have a sprint number 2, and my colleague Trevor said, well, we really couldn't have had the second sprint unless we went through that process of getting together and talking. And so I suppose there's something to that. So this time we met in Philadelphia, and we had a similar cast of characters that came. We had even more data providers. Now, one of the things that we did this time that was a little different was that we had our own engineers that came to the sprint in order to provide some actual coding experience rather than taking the risk that the people that were going to attend were just going to sit down and start implementing something. And so we had 2 front-end engineers and 2 back-end engineers. And our goal was to create a draft spec. We were less concerned with getting that all formalized and the documentation around it. What we really wanted was we wanted to demonstrate how this would work. So we had a back-end using public data. We thought that we could task Landsat data. Landsat is a known orbit. We know when the data is going to be collected in the future, and so we could implement a tasking API that returns Landsat or Sentinel as options. So that was the original idea. So before the sprint, we developed a back end that we could serve up that Landsat data, but it was also a pluggable back end so that if somebody else wanted to develop a proxy to their own API at one of the existing satellite companies, they could do that. And then we created a UI to demonstrate how a user would go through this process of ordering, seeing options, and then ultimately placing an order. We wanted to leverage existing standards where possible, so GeoJSON, STAC, I'll get to that in a second, and OGC APIs. And just like we did with STAC, the focus here is on the end users. In OGC, there's something called the Connected Systems API, which can control all manner of devices. But what we're after is something simpler and more focused on the user, just like with STAC. We don't want users to, like I said, they're not actually tasking the satellites. We don't need complex parameters. People aren't ordering swaths of data. They want data for this area at a certain time for this product. And that's as simple as we want to get, with some perhaps optional parameters based on the type of product that it is. We had a bunch of lightning talks from existing satellite providers, which was great. We saw Umbras and Planets and Capellas and Black Sky, all of their different APIs that they surfaced to users. And this was really, really great in order to see how the different business models work, because they can actually be quite a bit different. For instance, Planet has an option where you can put in a request and you can pay for it, and you pay for it. And if it's cloudy, you're out of luck. And not everybody does that, but it's a guaranteed collect. Whereas like Umbra will give you choices, but then you can have a threshold for when that might be met in terms of some sort of quality metrics. So they're all a little different, and so the challenge was how can we meet all of the ways that these different satellite companies serve up data in a single API. So at the beginning of the sprint, I posited this. Since we didn't make any progress, I thought everybody kept on bringing up STAC. Like maybe this is just a STAC extension. And so we thought, well, maybe a task is just a STAC item that doesn't exist yet. And so we went through that thought experiment and very quickly determined that actually this is not STAC at all. A single task can actually be made up of multiple STAC items. Like if you have a really large area, the data provider is going to have to actually task multiple collects in order to fill that whole area. And so that might ultimately be delivered via a dozen STAC items, let's say. And so right there we had a problem because we didn't want the user to have to worry about how that area was going to get covered. There's also no ID, because if you require an ID on this, then you're telling the data provider immediately that they have to store the state for every single feasibility request that they get. And that's not very practical either. A data provider can give some options, but if they have to track every single request just to see what's possible, that we didn't want that to be a requirement. Of course, they could track that if they wanted to. Perhaps most importantly is there's no assets in a future item. We don't have any assets yet until it's collected. And finally, we have unknown final values. So we might have a range of date times for which this is ultimately going to be collected. We might have a range of view angles, but we don't actually know what those final values are. And so in STAC, there are discrete properties, and they're single values. But in tasking, it's going to be some sort of range, and ultimately it'll be fulfilled with something within that range. So what we're looking at here is something that's like STAC, and ultimately would be delivered with one or more stacked items, but it's actually not stacked until that point when the data is actually collected. So somebody at the sprint used the term STAC friends, and it's sort of like that. We want to align with the STAC naming convention. We're using GeoJSON just like STAC does, but it's not going to actually conform to the STAC spec. We ended up with 3 core entities. We have a product. Every satellite provider is going to have to provide at least one product. This is a stereo image, it's an optical image, it's a SAR image. It's a interferometry, so a pair of SAR images that are used for interferometry. Like the product could really be anything, and maybe it's something even higher level than that. Like maybe it's NDVI or something. They can determine what exactly that product is, and along with that product is all of the parameters and constraints that users can provide when they order the product. We also have an opportunity. I talked about feasibility requests. We ended up on the term opportunity, which is what a lot of the satellite providers use. And this represents a window of opportunity. So you make a request, you get back several opportunities, and you can select one of those, and then you can order that opportunity. Now, what I said before is that there's different business models. Some providers will send you back these opportunities and give you these options, and others will they want the control over when that's ultimately going to be fulfilled. So they take in a single request, and you really only get back one option. And so we ended up on this workflow where getting opportunities is actually an optional step. So you can think of a user places a request, they provide spatial, temporal parameters and a product name, and they make that request. Now they can either go straight to the order endpoint, and then it's up to the satellite provider to determine when within all of the best how to meet that, or they can hit an opportunities endpoint, get back a bunch of options, they can select it, and then they can send that to the order endpoint. So we have a way to provide the user more options, or the satellite provider can simply just implement this single order endpoint if they want the ultimate control. We used FastAPI in Python and worked on an implementation after we had the basic concepts together. It was actually all sort of happening at the same time. And luckily, Umbra, Black Sky, and Planet all sent people who were just excellent engineers and were just ready to jump right in and start doing stuff. And so we created this UI. Everybody sat down in a room, and these three companies created backends using this pluggable architecture here that we had as proxies to their existing APIs. So the UI really became a sort of federated capability where now we can put in a request and we can get back responses from multiple satellite providers. So what we ended up with was really this federated tasking UI. And in the end, we had it implementing Black Sky, Planet, Umbra, and Landsat, which ended up being really not all that interesting since we had these other three. So it was initial proof of concept. We have three major satellite companies. Also, different types of sensors. Umbra is, if you're not familiar with them, they launch SAR satellites. Of course, Planet is optical. Black Sky kind of has a mix of a bunch of different satellites. And so it was a really great mix, and they all kind of work a little differently, and we got this all working within this single API. So what's next? What's next is we're going to have another sprint. And focus, just like I mentioned in STAC, it's really all about adoption. Our goal here is to get 6 or more implementations of this from these major data providers. So if we can get Planet, Black Sky, and Umbra, and then 3 or 4 more, that's the goal of the next sprint, along with a draft spec. And that's it. There's a couple blog posts about the 2 sprints on this, and there's an open public repo as well. Thanks for the time. I guess there's time for questions.